Own price elasticity of demand, E sub P, measures how much the quantity demanded of a good responds to a change in its own price. Formula, E sub P equals percent change in quantity demanded divided by percent change in price, equals delta Q over Q divided by delta P over P. Because price and quantity move in opposite directions for a normal downward sloping demand curve, the sign of E sub P is usually negative. In practice, we often report the absolute value. Interpretation. Absolute E sub P greater than 1. Demand is elastic, quantity reacts more than price. Absolute E sub P equals 1. Unit elastic, proportional response. Absolute E sub P less than 1. Inelastic, quantity reacts less than price. Numerical example. Suppose the price of a coffee cup rises from $2 to $2.20, a 10% increase, and weekly sales fall from 1,000 cups to 950 cups, a 5% decrease. E sub P equals negative 5% divided by plus 10% equals negative 0.5. The absolute value 0.5 less than 1, so demand is inelastic. Customers are not very sensitive to this small price hike. Explanation: several factors shape the magnitude of own price elasticity. Number 1, availability of close substitutes - more substitutes make demand more elastic. Think of soda brands. Number 2, proportion of income spent - expensive items. Cars tend to have higher elasticity than cheap staples, salt. Number 3, time horizon - consumers adjust more fully over time. So long-run elasticity greater than short-run elasticity. Number 4, definition of the market - broad categories food are less elastic than narrow ones, organic quinoa. Number 5, necessity versus luxury - necessities are usually inelastic. Exam classification tip: write down the numeric absolute E sub P, then label. If greater than 1, elastic, for example luxury watches. If equal to 1, unit elastic, theoretical midpoint. If less than 1, inelastic, for example gasoline in the short run. Remember to justify with the determinants above - examiners love a brief why statement. Explanation. Income elasticity of demand, E sub Y, captures how quantity demanded reacts to a change in consumer income. E sub Y equals percent change in quantity demanded divided by percent change in income, equals delta Q over Q divided by delta I over I. Positive E sub Y indicates a normal good, demand rises when income rises. Negative E sub Y indicates an inferior good, demand falls when income rises. Magnitude tells you how strong the response. If E sub Y is greater than 1, the good is a luxury, demand rises more than proportionally. If 0 is less than E sub Y and E sub Y is less than 1, the good is a necessity, demand rises but less than proportionally. Sample computation. Income grows from $40,000 to $44,000, a 10% increase. Sales of premium gym memberships rise from 200 to 260 members, a 30% increase. E sub Y equals 30% divided by 10% equals 3.0, which is positive and greater than 1, so premium gym memberships are a luxury normal good. Cross-price elasticity of demand, E sub XY, measures how the quantity demanded of good X reacts to a price change in good Y. Formula: E sub XY equals percent change in quantity demanded of X divided by percent change in price of Y equals delta Q sub X over Q sub X divided by delta P sub Y over P sub Y. Sign interpretation. Positive E sub XY indicates substitutes. When Y becomes more expensive, demand for X rises. Negative E sub XY indicates complements. When Y becomes more expensive, demand for X falls. Worked example. The price of butter rises from $3 to $3.6, a 20% increase. Cheese sales increase from 500 units to 550 units, a 10% increase. E sub XY equals 10% divided by 20% equals 0.5. Positive, indicating butter and cheese are substitutes, but the elasticity is less than 1, indicating a relatively weak substitution effect. The link between elasticity and total revenue, TR equals P times Q, is key for pricing decisions. Elastic demand, absolute E sub P greater than 1. A price cut raises total revenue because the percentage increase in Q outweighs the percentage loss in P. Graphically, the demand curve is flatter. In elastic demand, absolute E sub P less than 1. A price increase raises total revenue because the loss in Q is proportionally smaller than the gain in P. The curve is steeper. Unit elastic, absolute E sub P equals 1, total revenue is maximized. Any price change leaves TR unchanged. On a graph, the midpoint where the TR curve peaks corresponds to absolute E sub P equals 1. In exams, draw a simple demand curve, mark two price quantity points, calculate TR, and show the direction of change based on the elasticity sign. Short-run versus long-run elasticity reflects how much time consumers and producers have to adjust. Short-run elasticity, factors are fixed, for example number of factories, habits. Quantity responds less, so elasticity is smaller in absolute value. Long-run elasticity, all inputs are variable. Consumers can find new substitutes, firms can enter or exit. Elasticities are larger, closer to or beyond 1. Typical MBA exam numbers. A short-run price elasticity of demand for gasoline might be minus 0.2, while the long-run elasticity could be minus 0.7 or even minus 1.0. Remember to state the time horizon when giving an answer. Not doing so is a common grading penalty. Elasticity of supply, E sub S, shows how quantity supplied reacts to a price change. Formula: E sub S equals percent change in quantity supplied divided by percent change in price, equals delta Q sub S over Q sub S divided by delta P over P. Determinants. 1. Production lag. Goods that can be produced quickly, fresh fruit, have higher E sub S. 2. Spare capacity. Firms with idle factories can increase output easily, raising elasticity. 3. Factor mobility. Easily movable resources, labor, increase E sub S. 4. Time horizon. Long-run supply is more elastic than short-run. Comparative numeric example. Suppose price of steel rises 15% and firms can increase output from 100,000 to 115,000 tons, 15% increase. E sub S equals 15% divided by 15% equals 1, unit elastic supply. If the same price rise leads only to a 5% output increase, E sub S equals 5% divided by 15% equals 0.33, inelastic supply, typical for industries with long construction periods, for example nuclear plants. Comparing with demand elasticity helps predict who bears the burden of a tax. Pricing strategy: if demand is elastic, a firm gains more revenue by lowering price, for example airline tickets. If demand is inelastic, raising price boosts revenue, for example prescription drugs. Tax incidence: the side with the more inelastic curve bears a larger share of a tax. Example exam problem: a $2 per pack excise tax on cigarettes, where demand elasticity equals -0.4 and supply elasticity equals 0.8. The tax burden on consumers equals E's divided by the sum of the absolute value of ED and E's times the tax, which is 0.8 divided by the sum of 0.4 and 0.8 multiplied by $2 equals $1.33. Producers bear $0.67. Welfare analysis: deadweight loss from a tax is larger when either demand or supply is elastic because quantity falls more. In an exam, draw the supply-demand diagram, label the new equilibrium after the tax, shade deadweight loss, and explain using the elasticity values. Calculate elasticity. Remember to use the midpoint arc formula. E equals delta Q divided by the average of Q1 and Q2, all divided by delta P divided by the average of P1 and P2. Forgetting the midpoint leads to wrong numbers. Interpret the sign. A positive cross-price indicates substitutes, a negative cross-price indicates complements. A positive income elasticity indicates a normal good, a negative indicates an inferior good. Mixing up the sign is a frequent mistake. Revenue implication. Students often reverse the direction, thinking a price cut always raises revenue. Tie the answer to whether the absolute value of price elasticity is greater than 1 or less than 1. Short run versus long run. If the question mentions over time or after adjustment, answer with higher elasticity. Tax incidence. Use the formula. Burden on consumers equals supply elasticity divided by the sum of the absolute value of demand elasticity and supply elasticity. Forgetting the absolute value on demand elasticity flips the result. Pitfall to avoid, ignoring units, percentage versus decimal. Pitfall to avoid, not stating the assumptions, ceteris paribus, small changes. Pitfall to avoid, leaving out the economic intuition after the math,